simplify this expected value. Now we notice here we've got two random variables in here, two binomial random variables, and they're being combined. If we wanted to call one of them x and the other one y, just to clarify, what we're being asked for is the expected value of 2x minus y. Now we know how to deal with two or more random variables in our expected value. That's one of the things we learned in the lesson. Okay? So what's going to happen here? Well, let me show you sort of the quick with the x and y version of what's about to happen. Okay? Expected value allows constants to pop out. So we get 2x squared, and we'll get a minus, sorry, not x squared, 2e of x, 2 expected value of x minus expected value of y. Now for the purists in the class who say, well, no. We learned this turns into a e of x plus b e of y plus c. Nobody said anything about minus signs. Well, you're right. We never said anything about minus signs. But we didn't really have to. Because a and b can be any real numbers you want. So if I let a be 2, let's let c be 0 just so it goes away. And if I let b be minus 1, then what's going to happen? Well, the 2 comes out and the minus 1 comes out. And the 0 we can just ignore now. And you say, okay, I'll buy that. But what's plus negative 1 times e? Well, that's the same as minus e of y. And what's plus minus 1 of y? Well, that's the same as minus. So that's why we've never really mentioned in any of our formulas what happens when you subtract b or subtract y. Because it's really the same as using just a negative constant out front. So that's the idea behind this question. Now let's actually answer it. So we want the expected value of 2 times a binomial random variable. I believe it was 5 1/3. And then minus binomial random variable doing something 4 times and counting up the number of times that something that happens 1/6 of the time occurs. Right? So now we can take our constant 2, okay, and sort of our constant negative 1, so we just leave it as a minus sign, and those can come out. Okay. And we're left with the expected value of, oops, don't need the 2 anymore, do we? Expected value of a binomial random variable minus the expected value of another binomial random variable. But fortunately, in previous lessons, we've learned how to do formulas for expected value. So we'll have the same 2, and then what is it? It's n times p, so 5 times 1/3, and then minus 4 times 1/6. So 2 times 5 is 10, so we'll get 10/3, minus 4 over 6 becomes 2/3. We get our answer here, 8/3. And that's our final answer. The expected value of this complicated looking binomial, it's not even binomial anymore, this complicated looking combination of binomial random variables, expected value is just 8/3.